Okay guys, today we're doing 6.7 and we're integrating the natural log. Okay, so last lesson we integrated exponential functions. Today we're integrating the inverse function of exponentials, which is the natural log. Okay, let's get started. First thing, just like we did with e, is with the exponential functions, we're going to talk about just some basic properties you need to know about it. Okay, first graph it. Okay, I hope that you are still graphing it the way I showed you, where you go like that, and you make sure it crosses right there at the 1. And if I get on a graph, I'm going to try to do it a little more appropriately. I did not do very good, but it crosses right there, right? And that little weird thing should not be in there. Okay, so natural log of 1, you should know, is 0. Okay, and then when does natural log of x equal 0? Okay, actually that's at 1. I think I meant to say what is the natural log of 0? And to that you would say does not exist, right? There is no point at which natural log has 0 inside of the function. Okay, so any negative value as well. So you'll never have a natural log of any negative number at all. Okay, that will always be does not exist. Okay, let's get started with this. Okay, so if you were to, let's just try taking the integral of this. Okay, so let's try taking the integral of this one. So first thing you would do is you'd move it to the top. You have x to the negative 2 dx. And if you had that, I'm hoping that what you would do is you try to boost and divide. So boosting it would make it negative 1 over negative 1, because it's boost and then divide, right? Plus c. And this rewritten is 1 over, and you could put the negative that's right here, you can put that on top or the bottom, it doesn't really matter. I could put it out in front too. X plus c. Yeah, that is the integral of that. Okay, let's try that exact same method with this one. So we're going to move that to the top. So we're going to have x to the negative 1 dx. Okay, boost and divide. So boost this. Negative 1 plus 1 is going to be 0. And divide. Then don't forget your constant. And this, you can never divide by 0. Any number raised to the 0 is just 1. So this numerator here, that's 1. But this, you can't have a 0 on the denominator. Remember, we've spoke about this several times in the past, especially when we're doing limits. You cannot divide by 0. So this is incorrect. You can't do that. Okay? But how about I show you guys something? Let me see if I got it on the next slide here. Okay, I didn't, but let's say I have the natural log of 2x. Okay, and I said, take the derivative of that. Okay, well, if you were to take the derivative of this, remember, the derivative is going to be du over u. And remember, your u is going to be the stuff on the inside, and du is going to be the derivative of that stuff, which is 2. Okay, du over u would mean 2 over 2x, which is the same as 1 over x, right? So, if you were to do the opposite of this, you get natural log. Yeah? So, when you're doing the integral of this, when you have something with a 1 on the denominator, if you try to do that the other way, you're going to end up with that. Okay, boosting and dividing gives you that. This is the calling card telling you you cannot do this. So there must be some other rule you know. So the integral of 1 over x, since we know the derivative of natural log is 1 over x, we know the integral of 1 over x is going to be natural log of x. But remember, what did I say you can never have on the inside? On the last slide? I said you can never have a natural log of a negative number, right? Okay, so in order to avoid all negative numbers, what we're going to do is we're going to put a natural log. We're going to put an absolute value for that natural log. So whenever you're doing this, the integral of this is going to be natural log of absolute value of x. And here are the more formal definitions. The integral of 1 over x dx is the natural log absolute value of x. If there's something else down here, like it's not just x, we can use u substitution, and it's going to be 1 over u is the integral of 1 over u is natural log of u. Still with absolute values. That's important, okay? If you forget those absolute values, you're going to get it wrong. Okay, so how do you know when to use a natural log? That's going to be when you boost and divide. And if you boost and divide and get like x to the 0 over 0, that's key. It's a natural log problem, okay? And also when it has multiple terms on the denominator. So like let's say we have the integral of 1 over x squared plus 5 dx, okay? We can't break this up like we used to. Like this is not the same as 1 over x squared plus 1 over 5 dx. That is not the same thing. This does not equal this. Okay, so you can forget about that. That's going to be u sub. Let me show you through a couple examples here. Okay, this first one. Now I hope that you see this one and there's only one term on the denominator, so you realize, oh, I can split that thing up so it has 6x cubed over x plus 2x over x dx. Okay, and then doing this, I'm going to get 6x squared plus, and it's still the integral, 2 dx, and the integral of this would be 6x cubed over 3 plus 2x, that's boosting and dividing, right, plus c. That's just going to be 2x cubed plus 2x plus c. Okay, now I could do all of that because there was only one term on the denominator, right? Let's do one that has two terms on the denominator, okay? So something like this. So if you're looking at this, you have two terms on the denominator. I can't break it up like I did on the last one. I can't make this 7x over x squared and 1 over 5 or something like that. I can't do that. So whenever you see more than one term on the denominator, it's automatically u substitution, okay? U is going to be the denominator, okay? The derivative of it is going to be your next thing to do, and that's going to be 2x dx. And remember, you solve for dx after that, which in this case would be du over 2x. First three rules, just like always. We're going to have the integral of 7x over u. Yeah, because this is u. And then dx is going to be du over 2x. Okay, well, those x's can cancel out, leaving me with the integral of 7 over u. And I can put that 2 in the front of u. Yeah? Remember, this divide sign is really over everything. So all these things are multiplied and crossed. So I can move that 2 behind it, in front of it, wherever I want, and then du. If you want to write that du on the top with the numerator, you can, but I'm not going to. Okay, what I have here is I have a term with an exponent of 1 on the denominator. If I move that to the top and try to boost and divide, watch like this, I could rewrite it like this, right? And if I try to boost and divide that, I get 7u to the 0 over 2 times 0, yeah, plus c. I can't divide by 0. That right there, tells me it's wrong, and that tells me whenever I have something raised to the 1 that's on the denominator, the integral of it is going to be natural log of that thing. Okay, so my 7 over 2 just comes down, okay, and it's going to be natural log of the absolute value of u plus c. Okay, that's telling me that 1 is telling me that's the natural log, that the integral of it is natural log. Now the coefficients stay on the outside of the natural log, okay? So this is going to be the same as 7 over 2 natural log of the absolute value of x squared minus 5, because that's what my u is, plus c. And there's my answer. Okay, so let's go to this next one right here. Okay, now I know it's going to be u sub because I see two terms on the denominator. There's two terms there. So my u, du, and dx, I can write out. U is going to be the denominator with more than one term. Okay, now I'm going to take the derivative. The derivative of 5 is nothing. The derivative sine is cosine of, and remember you leave that alone, and this is chain rule, times 3. Yeah? And then don't forget your dx at the end of that. And I get to solve for dx, so that means I'm dividing by this whole thing. So I'm going to have du over, and I'm going to move this 3 to the front. So it's going to be 3 cosine of 3x. I mean, you can leave it at the end if you want to. Doesn't really matter. Okay, I did my first 3 steps. Next step is substitution. We're going to have the integral of cosine of 3x over u, and then my dx is going to switch out for du over 3 cosine of 3x. Now look at that beautiful thing there. It cancels out, leaving me with just the integral of 1 over, I'm going to move this 3 in the front, du. 1 over 3u du. And this has an exponent of 1. Now if you try to move it to the top and boost and divide, you're going to run into this problem. That's telling you, okay, now I'm going to rewrite my coefficient. It's telling you this thing is the natural log of the absolute value of u plus c. And then don't forget to substitute in your u. So it's going to be 1/3 natural log of, my u is 5 plus sine of 3x. 5 plus sine of 3x plus c. And there's my answer right there. That's the integral of that. Okay, now I think I might have one more slide. Oh, I don't. Okay, I do want to go back real quick to this one. I want to switch this up to make it a little something special here, something that I saw when I was doing the integral here. Let's get rid of this x here. So instead of doing this, let's do the integral of 6x cubed plus 2 all over x dx, okay? So ignore that one. I'm going to do this one, okay? It's going to be have a natural log in here. That's why I want to do it. So since I only have one variable on bottom, I can split it up, right? So I'm going to have 6x cubed over x plus 2 over x dx. Okay, I can rewrite this first term to be 6x squared, because we're subtracting exponents, right? And then this is going to be just plus 2, and then you can move it to the top or you can leave it how it is. Whatever you do, you're going to notice that when you do this, we're going to boost and divide, right? So let's boost and divide. It's going to be 6x cubed over 3 plus, now what I'm going to hope you're going to see with this term is if you boost it, you're going to run into that problem, right? Right there, dang it, that's the problem. That's telling me that this is going to be with a natural log. Now this term was boost and divide, so I can leave that term how it was. But this term is just going to be 2. Okay, I'll write it underneath it, 2, and then remember natural log of the absolute value of x. And don't forget your plus c. So my answer here for this term was the integral of this term was with natural logs. The integral with this term was with boost and divide. So this can simplify, can be 2x cubed, right, plus 2 natural log of absolute value of x plus c. And that's the answer right there. Now I do want to just review something real quick. Anything with natural logs, remember that number in the front? If you go back to pre-cal, this can be rewritten as natural log of x squared. That and that are the same thing, right? So I just want to let you know that on the exam, they might not leave it like this for this middle term. They might write it something like this, 2x cubed plus natural log of absolute value of x squared plus c. Because those two things are equivalent. They're the exact same thing. So I don't know how they're going to write it. So it's up to them. Okay, so I just want to make sure that you notice those things can be written as exponents. Same thing as some of the other ones we had before was like 7 over 2 natural log of x. Yeah, I think that was one of the answers that we had earlier. This can be rewritten as natural log of x to the 7 over 2. Yeah, which is the same as natural log of, remember, division by 2 is a square root. So it can be rewritten like that. Yeah? So there's a lot of different ways they can write these natural logs. And I don't know how they're going to do it, but you need to be able to switch between them if you're going to get these right. Okay, and good luck on the worksheet.